All right, so Charles Darwin designed an experiment to compare the effects of cross-fertilization on the size of plants. He planted pairs of very similar seedling plants, one self-fertilized and one cross-fertilized, in the same pot at the same time. After a period of time, Darwin measured heights in inches of all the plants, and here are his data. So yes, cross-pollinating and self-pollinating is what the cross and self are. So, doesn't matter whether a plant is self or cross-fertilized, construct a 90% confidence interval and state your conclusion. So right now we've got our two lists, but I'm going to find the difference in them. So L3 is where we're going to store this. So L3 is going to be the change, and that's going to be L1 minus L2. So you just do second stat, and then it'll give up the list. So L1 minus second stat L2. And then when you hit enter, it's going to bring up like the curly Q parentheses of numbers. Then you're going to hit the STO button in the bottom left corner, which is going to store it. And then you're going to hit second stat L3 and store it in L3.
Wait, can you backtrack for me?
Where?
So, L1 minus L2, and
Hit enter. And then hit the store button. STO in the bottom left corner.
I think I might be in the wrong place because I didn't actually put that.
Okay, L1 minus L2, and then you do,
Where'd you do it?
and then you just, wait, what do you mean?
Did you do it in the list?
How are you in the wrong place?
Where's this one?
It's at the bottom
Right
left.
there. It's above the on.
And then you just hit second stat and then L3 to store it in L3.
Yeah. And then to check, you can do stat and then edit.
Yeah, and then you'll see the numbers in L3.
Is it up there?
Yeah.
All right, so let's look at our conditions before we go too much farther, just because we have that one condition that's a little different with this stuff. So paired data. This is the only one I'm actually going to write everything out for, just because the other ones are the same stuff we've been doing. So for paired data, while these plants aren't the same, because obviously each one's are different, but the plants aren't the same, but they're similar in pairs. Because one's cross-pollinated and one is self-pollinated within that particular pair. So that's fine to do paired data for that. Obviously, the ones we'd seen so far had pretty much been like before and afters and things like that, but this one's just a little different. For independence, is each pair independent?
Yeah.
Yes. More than likely, just because he said he used very similar seedling plants, more than likely he didn't use the same type of plant for all the pairs, but it doesn't specify enough for us to be sure. But more than likely it's different types of plants, but then within that each pair would have been the same kind. So like 2 sunflowers, 2 daisies, 2, so on and so forth.
Okay.
So independent, I'm not going to write it all out, but good there. Random or representative sample.
Yeah.
Yes. Um, 10% condition. Yeah, 15 pairs of plants is definitely less than 10% of all plants. And nearly normal. We could check histograms for these if you were so inclined by putting them in the stat plots for L1 and do a stat plot, not a stat plot, a histogram for L1 and a histogram for L2 if you want to look at it and see, but they should be pretty symmetric, and I don't really see any numbers that are obnoxious one way or the other that I would think are outliers particularly. So I'll just make a note here to check histogram if you are doing it. All right, so the goal here is to construct a 90% confidence interval and state your conclusion. So the tendency is we have two different sets of data. We should use a 2 sample t interval or something like that. However, we have found the differences in them, which is what we're looking for. So we are going to actually just use t interval. So stat test t interval, and it's going to be for data. This is going to be L3, so you're going to have to change that. Normally what our stuff is an L1, but L3 is going to be it. Frequency of 1, confidence level 0.9, and so when we do that, what interval do we get?
0.463, 4.7.
Yep. Run one variable stats on L3 so that we can do it by hand as well. Actually, we don't really need, never mind. You don't actually need to do it since we've already done it this way. But, well, do it using one variable stats for a refresher, because let's say you didn't have, no, obviously if you have your calculator to do one variable stats, you don't have to worry about it. Second, is it stat? Nope, not second stat. Stat calc, one variable stats. So obviously you would kind of have to have your calculator either way for this question, but let's say they wanted you to, it was one of those, multiple choice questions where you needed it written out by hand instead of just giving what the final answer to the interval would be. You would need to use one variable stats to get there. And so what is the D bar? So what's the mean? It's going to be listed as X bar in one variable stats, but 2.61. Okay. How about standard deviation, S? 4.71. And we had N is 15 because we had 15 pairs, so what are our degrees of freedom? 14. So if we were going to do this by hand, the setup would be our confidence interval is, it's the D bar, so 2.61 plus or minus T star for 14, and it's at a 90% confidence, so at 0.1 for the two-tail probability, down at 14, so it'd be 1.761. I know you can't read this, but 1.761 would be that number. Did I ever print y'all one of these? The T-table? Let me do that. Thought the other day when I was printing stuff that I did, but I guess I didn't. Times the standard deviation, 4.71, divided by the square root of N, which is 15. And so then you could also do it this way by hand. Or that would be the setup of what it would look like by hand if you needed to do it that way. And so from that, any idea what my conclusion would be?
Based on the sample, I am 90% confident that cross fertilized plants will grow between 0.463 inches to 4.75 inches taller than self-fertilized plants.
Based on the sample, I'm 90% confident that the cross-pollinated plants grow on average 0.463 inches to 4.75 inches taller than self-pollinated plants.
How would you decipher that?
So if it was negative, it would be like if the if the numbers we got were negative, would it be shorter then?
Yes, if you did it doing L1 minus L2.
Oh.
Now, if you had done it backwards, because when I initially typed it in the first time, I did L2 minus L1, and so my numbers were flipped, and I think backwards. No, I don't have it on here anymore. But they were flipped in negative, so the 4.75 came first, and it was negative. And so that would have just told me that the self-pollinated plants were 4.63 inches to 4.75 inches shorter than cross-pollinated. So the context is based on which order you do it in. So not that there's a right or wrong order to do them in. It was just kind of like do L1 minus L2, which is what I thought I did the first time, and then I realized I typed it in backwards.
Okay.
I like went back and I was like, how come? I was like, I thought my answer was going to be positive, and then I was like, oh. But it just, the conclusion is just, I mean, it says the same thing, it's just written differently.
Yeah.
I mean, you could have still come to that conclusion with the way this was written, but, you know.
I understand.
Next one.
Dairy cow.
It's a good question right there. All right, many dairy cows now receive injections of BST, a hormone intended to spur greater milk production. After the first injection, a test herd of 60 cows increased their mean daily production from 47 pounds to 61 pounds of milk. The standard deviation of the increase was 5.2 pounds. We want to estimate the mean increase a farmer could expect in his own cows. All right, so check assumptions and conditions for inference. So, paired data. What situation are we dealing with here?
Before and after.
So before and after. So same cows, before and after.
So, is parent data like not necessarily like a condition that it has to meet? It's just like what?
It's kind of like, how are we verifying that it's paired?
Okay.
So like before and after, or the last one, how it was like a literal pair that were similar in type or whatever, or like the same type, but it's a
Okay.
pair of them. Obviously, like we said on that one, it's not the exact same plant, but since they're the same, you know, like both sunflowers or something, then it's fine.
Yeah. Okay.
So most of the time, we're dealing with a before and after. like we did, like the one with the test yesterday.
Yeah.
All right, independence. Is each cow independent of the other?
Yes.
Yes. So cow's independent. So like one cow's production does not affect another. Random or representative?
Yes.
Which one?
Oh.
Representative.
Representative.
Yes.
So it's a representative sample, because obviously it indicates that it's just from one particular farm, I think. Or well, from that specific farmer's herd, so representative of all, you can assume. 10% condition is 60 cows less than 10%.
Yes.
I'm just gonna put a check mark by that one. And nearly normal, do we know?
It's 60
It's
cows,
60, so it's
so
more
it's
than
above
40,
40.
So we should be safe to continue. So nearly normal, greater than 40. So it doesn't say specifically, but because it's 60 cows, we're gonna go on the assumption that it's A-okay. All right, so what are my degrees of freedom so that I can answer the next question? 59. All right, so we have, I'll write the formula here, D bar plus or minus T star degrees of freedom times S over the square root of N. So the D bar value, this is a little different in this one because the last one when we did it, we already had like our X bar from our one variable stats, but in this one it went from 47 to 61 for the mean. So that means when I find my D bar, it's the mean of the difference. Okay? The mean of the difference was already accounted for in the last one because that was our L3 value that we ran it for. If we hadn't done that and we had found each mean individually, we would have had to subtract them to get our D bar value.
Okay.
But since we did it for L3 in that last one, we were good to go. So this one's going to be 61 minus 47 plus or minus, this is a 95% confidence for T star for 59. So 0.05. Now 59 isn't on here. So what do we do when that
We go to the closest.
You go down.
we go down? Because the temptation would be, well, it's close to 60, so go to 60, but it's actually going to be to 50, so 2.009. And then S, so the standard deviation we are given of, it says of the increase, that means they've already taken it for the difference, so that's 5.2 over the square root of N, which was 60. And so we could do it out that way. I think we can also do T interval again. Not if I hit the wrong button though. So it should be able to run a T interval with stats again. The difference when we do it this time is that we're going to have to go ahead and find this difference. So 61 minus 47, which if you type it in, it's going to do it. If you type in 61 minus 47, it's going to automatically solve it for you. Standard deviation, 5.2. N is 60. Confidence level, 0.95. So this one, if you typed it in, would be T interval, stats, 14, 5.2, 60, 0.95. And when I do that, I'm seeing 12.66 to 15.34. And if you did that by hand, you should get, within a decimal place or two the same thing. So what does our interval mean in context? And remember, this is pounds of milk over here.
Based on the sample, I am 95% confident that
And I would be specific when you talk about the kind of cows and say the specific name.
the
Yeah.
that like the something about like the increase in milk in the Ayrshire cows, like increase in their daily production of milk, like is an increase between 12.6 and 15.34 pounds.
Yeah. Something along those lines. Yeah, would be fine. So I'm 90% confident that the cow's receiving the BST injection, and it doesn't have to be written exactly like this either, but will increase milk production by 12.66 pounds to 15.34 pounds on average, because I forgot to write that before. So, given the cost of BST, a farmer believes he cannot afford to use it unless he is sure of attaining at least a 25% increase in milk production. Based on your confidence interval, what advice would you give him? So, we need to figure out what a 25% increase would be from the original amount that he started with. Okay, so you started with the cow producing 47 pounds. So, how would I find a 25% increase? Or like what that amount of poundage would be.
Multiply it
Add
So it would be 11 pounds.
Yeah, multiply by 0.25, so 47 times 0.25,
11.75.
so 11.75 pound increase. So, okay, now we found that he wants at least an 11.75 pound increase. So based on our confidence interval, should he purchase this BST or not?
You should.
Yeah.
'Cause that's below the confidence.
Yep. He should do the injections. Maybe not if he wants organic cows, but he should do the injections because our sample indicates he shouldn't see an increase of more than 25%. Before I'll go in one and after I'll go in another. Alright, so before is going to go in L1. After is going to go in L2. Helps if you put your stuff in the right list.
I don't know. Are you?
Alright, so one indicator of physical fitness is resting pulse rates. Tinman volunteered to test an exercise device advertised on television by using it 3 times a week for 20 minutes. The resting pulse rates, which is in beats per minute, were measured before the test began and then again after 6 weeks. Results are shown in the table. Is there evidence of that this kind of exercise can reduce the resting pulse rates? So based on that, what is my hypothesis here? In terms of the difference. The null would be what of the difference?
No, would be
What is our null always?
equal to.
It's equal to, so that it stays the same, there's no change. Alright, so then what are we looking to see for our alternate?
Reduced resting pulse rate. So we would say that it's
Not less than. Yes.
because it's not less than 0.
Well, so that
The difference, right?
so it's the difference. So we would say, so it's trying to say that there's evidence that this exercise can reduce pulse rates, which means that the before would be higher than the,
So we would say.
so it'd be greater than.
Greater.
Yeah. So it'd be greater than 0. So let's go ahead and do the difference here. So it's going to be in L3, it'll be B minus A, so L1 minus L2 to produce L3. We don't have to write all the numbers down here, but just store them in the list again like you did before. And obviously these you could do by hand. I mean, what is this? 0, 4, 4, 1, 4, 8, 3, 2, -1, 3. So I mean, obviously you could do these by hand too, and just, but your calculator will do the list for you, so don't have to worry about it. All right, so assumptions. Paired data. Why? Yes, before and after. Before and after for same people. Is it independent?
Yes.
Yes, because each person's heart rate is different or like is independent of like themselves, like for
Yeah.
themselves.
Yeah. Someone's heart rate doesn't affect someone.
Yeah. Random.
So representatives.
Yeah. We're hoping it's a representative sample. I mean, it says 10 men volunteered, which could potentially, I mean, you know.
Yeah.
Did you get all the most athletic people already? Did you get people that are couch potatoes? You know, you just, you know. So anyways, we're going to hope that it's representative.
What is a good resting pulse rate anyway?
Usually in the 60s, I think. But it depends on how active you are.
'Cause I was looking at these and like that 99 is concerning.
Yeah, like 99.
If that's his resting heart rate, there's something wrong.
99
Yeah.
resting heart rate. I mean, and then the 91 is still not great either. Like,
Because mine is normally in like the 60s.
and 60s.
Mine's like upper 60s, low 70s, depending on how resting we're talking about.
Yeah, 99 is crazy. Like, he has some heart issues.
Well, my normal resting according to my watch is 64.
Am I okay if
So.
I have a 99?
This is probably a couch potato that never does anything.
Or can't stress.
Resting rate.
Or that too. Yeah,
I mean, none of these men seem particularly
Okay.
healthy.
that's true.
So it says the normal resting heart rate for adults ranges from 60 to 100. So a lower heart rate at rest implies more efficient heart function and better cardiovascular fitness. So this guy
That guy
has
is a
no
couch potato.
cardiovascular.
Definitely a couch potato.
He's
Bor-
a couch
bordering where we should be concerned.
potato.
Or maybe he just doesn't know how to take his resting heart rate. Who knows?
Yeah, that's true. He could just be counting wrong.
Be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11,
What do you do?
12.
Well, at least
Skip a
he
few
showed
hundred.
improvement, so.
He made an improvement because he exercised.
All right,
Or maybe you just learned how to count better.
nearly normal.
Okay, it's only 10 people, so it's less than 15.
Yeah, so it's less than 15. So it might be good to just look at something to make sure that there's no outliers. I mean, the 99 is a little concerning, but I still think if we checked outliers, it's going to be within that. Just looking at a probability plot or box plot, probably fine.
Yeah.
Fine enough.
Fine enough.
All right, so just for the practice again, let's run one variable stats on L3 because we've already done L3. So run one variable stats on L3. If you did it on something other than L3, you're going to have to do it as like 1 minus 2 to get the difference. All right, what did we get for our mean?
2.8.
2.8. How about standard deviation?
2.5.
And degrees of freedom would be what? So we could find our t value if we want. We haven't done this in a while, so t for 9 would be 2.8 minus 0. 'Cause So remember that number is basically always 0 unless they tell us something otherwise. Divided by 2.53 over the square root of 10. And what do we get for that?
Penmanship.
Okay, just making sure. I didn't know if it was.
You worked on your penmanship today, Emily?
No. And guess what Liam did?
What?
And Navy.
What?
They dunked their heads in the water fountain. So
Wait,
I
aren't you over fourth graders?
Yeah, that's fourth graders.
Yeah,
I
that's-
told Liam to go dry his hair off, and he comes back with soaked, wet, like a wet head and soap in it.
So,
Yes. I told him to dry his hair off, and he was like, "Well, I have a different hair texture than yours, so you wouldn't know." And Miss Dent was like, "Don't talk to her like that."
wait, so
Like, there's
was it in
soap.
the bathroom?
Yes, I told
Oh,
him-
I thought you said water.
No,
fountain.
it was in the water fountain. so
Where
I
has to
told
get
him-
soap in the
I
water
told
fountain?
him no, bro. I told him to go dry his hair off, so he went to the boys' bathroom and then came back with a wet head and soap in it. Davey thought it was the funniest thing.
You're trying to wash his hair.
Yes. I said, well, his hair's like flat too. Like, he barely has any hair. I was so mad. It was Teacher Appreciation Week. I always forget that day. Like, or not
It's not
forget,
a
I
day,
get
it's a
What is happening?
Isn't that in May?
Oh, it's in May. Okay.
So you don't have
I'm
to worry
gonna
about that
forget
yet.
by then.
Well,
You gotta do
fair
it like
enough.
the week before.
We got, look, we have a whole thing for it.
Oh, that's so cute.
Monday is, I don't know if you're supposed to be hearing this, but Monday
think
you bring
everyone
a
got the
teacher a
email.
handwritten thank you card. Bring your teacher school supply on Tuesday. Wednesday, bring your teacher something that will bring them joy. Thursday, bring your teacher their favorite candy or snack. And then Friday, you treat your teacher with a $5 gift card.
Well, now she's gonna be expecting things.
They sent it to the
I feel
whole
like it's
school.
way easier for elementary kids because they have one teacher.
I know.
We have
Oh,
seven.
okay.
I'll
Well, actually,
probably
I don't
just
have
do-
seven.
I'll probably just do her.
Who?
Miss-
Do you even have a class with her?
Shh, he's my teacher. This one, I'm literally basically in the
You're
second
basically
one.
in physics.
Yes.
The second one's actually the third one.
I mean, the second one, like, last period, because I never go to teacher's aid.
All right, we're gonna run a t-test on here. So, stat test,
oh, yeah, 'cause we had a
t-test for data.
T-test.
Mu sub 0 is gonna be 0. List is L3. Frequency is 1, and we're looking for the greater than 1. And then hit calculate. And you're going to see it's going to produce that t value that we already found. What is the p value that comes out of that?
One, 0, 0, 3, 4.
3 decimal places is fine. Now, what is our alpha? If it doesn't specify, what do we say that it would be? 0.05. So my conclusion would be what? My p-value of 0.003 is what?
It's like lower than.
Is lower than alpha equal, whoa. 1.05. So what does that mean?
We
Reject the null.
Reject the null. And what does that mean in terms of evidence?
so
So, it did decrease resting heart rate. So there is a decrease.
So there's evidence to suggest the exercise program is lowering the resting pulse rates among men on average.
yeah, except for that one guy who
Probably, maybe he just
Gained
didn't
a
do
beat.
it. I think he just didn't do it.
he just didn't do it. He said he did, but didn't.
He's just like, I don't care.
Yeah. Or he has heart issues.
All right, last thing really fast. How much does this exercise program lower pulse rates? So this is going to be your T interval. And it's going to give you an interval of 0.99 to 4.6. And we'll wrap this question up tomorrow, but that way you have it. And then
So wait, so what? How many chapters is this test gonna be on?
just these three. 23, 24, and 25.
Oh. Oh, okay. I thought it was gonna be 23, 24, 25, 26.
So yeah, so tomorrow we'll finish answering this question, and then I'll give you the review questions. Part 1 will be Friday, and then the math part we'll either do Monday or Tuesday.